So good morning, everyone, and welcome to our session, Charting the Research Agenda, Advancing Building, Construction, and Carbon Dioxide Removal. My name is Azin Zari, and I will be moderator today. And it's a pleasure to have you all in person, actually. That's good. Yeah, okay. Oh, okay, sure. Yeah, okay. Thank you. So our agenda actually for today's session will begin with the opening remarks and followed by the keynote speakers and also with the audience engagement, and then we will continue with the panel discussion. So to begin, I would like to invite Professor Edel Guinter, Director of the United Nations University, to officially open the session.
Thank you thank you very much for being here. As you already saw in the agenda, we tap on two topics mainly. It's materials and it's carbon dioxide removal, and then we also have a panel discussion, and I will include in my opening remarks also the status of the priority action research of the buildings breakthrough of Global ABC. Can you? Wonderful. So when we look at buildings, we see quite nicely the energy demand on the one side, the importance of the building sector with 34% of energy demand, and if you look here, 37% of emissions by the sector. We at United Nations University, we take a nexus approach. That means we also include all the elements that you see here also on the screen, like air and water, but also plants, space in terms of square meters, so it's much more complex, and we touch on all the different resources. We are leading the priority action research of the Buildings Breakthrough Agenda, and I would like to present a few results of a survey that we conducted. Next. And we would start with a little video.
And side effects of climate and resources, ask your architect or civil engineer. Construction alone is responsible for more than a quarter of global CO2 emissions and consumes enormous amounts of resources that are already in short supply, such as sand. That's exactly what we want to change: construction without side effects. Our task is clear. Construction must become climate neutral and resource efficient by 2045. However, there is currently a lack of both research and rapid implementation of new ideas. When it comes to fundamental research in civil engineering, we are moving away from stereotypical thinking. In the future, we will focus on values such as humanity, circularity, and neutrality. The aspiration to construct buildings in which regional references are considered and human needs are central is one of the greatest values of humanity. After all, construction is profoundly human. Circularity is equally important, which implies that structures and materials remain in circulation. With the climate changing, the values of neutrality is of particular importance, especially climate neutrality. All research will take place in the region, supported by intensive international collaboration with leading institutions such as Harvard, MIT, Princeton, the Asian Institute of Technology, and the United Nations. But what good is the best research if it is not realized? Our second major task is to translate the knowledge we have gained into practice. For this, we need new and fast approval procedures that guarantee safety to the same extent as today. Both companies and regulatory institutions can operate best if they are located in the region and in close proximity to the research center. Many high-revenue companies have expressed great interest in research on climate-neutral and resource-efficient construction. Together, we are creating a basis for new construction without side effects.
And we will have a speaker who will introduce this center as the first speaker. We conducted a study among the members of the priority action research and asked 3 questions. We asked about research priorities and gaps. We ask about research networks, and we ask about existing initiatives. And these are the results that we got so far. So research gaps are considered in low carbon materials and construction, embodied carbon mitigation, industry research integration, but also energy efficiency, resilient and climate adaptive designs, also urban heat, circular economy, and then also two more social science topics, behavioral factors, where we also integrate different age groups, for example, different genders, and also the finance question. When it comes to research priorities, and this is what we will launch also here at COP30, we got a clear feedback from those answering the survey already that we should start with climate resilience and circularity, followed by energy efficiency, also finance effects, digitalization, and then again also down to the social and behavioral research. And we will then invite everyone to come up and be a member of working groups there where we can then discuss how to continue. Meanwhile, we have 29 experts, and maybe you will be number 2010. That's what we just discussed, from over 22 countries, so this must increase. 26 research institutions, also 12 ministries, we did that. So I ticked the box, more can come. We have the survey, and what we will do now after COP is that we will discuss in working groups how to advance the research priorities. Output can be recommendations for research funding. Therefore, I think it's quite interesting that we have ministries there involved, but also joint academic publications, contributions to the Global Status Report, and the new Global ABC platform, in order then to generate outcome. And really that is also the idea of also this session here at COP, that we have an impact on the member states, on the business sector, also on civil society. And with this, I hand us over to Asin.
Thank you very much to Professor Günther for setting the stage and highlighting the importance of the two-day topics. So, okay. Now we have a recorded video from Professor Viktor Mecherin, Director of the Institute of Building Materials at the Technical University of Dresden.
Yeah, good morning, everyone. My name is Viktor Mecherin from TU Dresden in Germany, and I'm speaker of the Cluster of Excellence CARE, Climate Neutral and Resource Efficient Construction. It's my great pleasure to present you this initiative. Let us jump right in. Construction is a truly fascinating field, tangible, diverse and monumental. It shapes our lives, providing comfortable homes, essential infrastructure and spaces for work and leisure. Its importance to society cannot be overstated. But let me ask, how do we build today? Concrete dominates construction, accounting for 80% of the total volume. Every year, the world pours enough concrete to build a staircase to the moon. The demand is astronomical too, and it's growing fast. By 2060, global construction activity is expected to double. But already now, construction is a major emitter of greenhouse gases and one of the largest consumers of energy and natural resources. The industry is also struggling with low productivity, labor shortages and high costs, all of which hinder its development. So the question is, can we overcome these challenges? Yes, we can, if we embrace such both new concepts as CARE, climate neutral and resource efficient construction. CARE represents a groundbreaking transdisciplinary science domain that integrates several pivotal research areas into a holistic approach. Our vision: carbon neutral, mineral-based alternatives to concrete synthesized through electrochemistry using carbon dioxide and waste, powered by renewable energy. But materials innovation alone isn't enough. Structural engineering must undergo a revolution as well. Our goal is to replace today's bulky, wasteful layouts with disruptive material-efficient designs based on circularity principles. At the same time, we will integrate fundamentally new monitoring and strengthening techniques to extend the lifespan of existing structures and enhance their safety. To boost productivity, quality, and safety, CARE will explore new methodologies to digitalize and automate fabrication and construction processes. These innovations will redefine efficiency while making construction more appealing and inclusive, especially for women and older workers. The groundbreaking transformation across these three interconnected areas of construction will be powered by novel digital methodologies, pioneering data-driven solutions across the value chain. Sustainability frameworks will predict and assess the sustainability and resilience of these innovations, providing clear guidance for our research efforts. This systemic approach positions CARE as both highly promising and uniquely transformative. And for us, it's extremely important to conduct fundamental research that addresses large-scale challenges and to facilitate technology transfer. Thus, CARE will validate and explore the game-changing paradigms through free physical innovation and collaboration platforms. While the next generation prefab plant is yet to be established, the other two platforms are already operational and will be expanded under CARE, the Future Technologies Experimental Construction Site at Aachen University and the CARE Life-Size Bridge near Dresden. Well, now let me address a little bit some scientific aspects of CARE. I want to start with the waste utilization. 35 billion tons of waste are generated annually, most of which ends up in landfills. CARE is committed to transforming this unsustainable pattern. The chemistry of these waste materials is often highly complex, with unknown hazards that could arise during the reuse in concrete. CARE addresses this challenge by creating physicochemical fingerprints with our new CARE data space, which will ensure traceability of these materials throughout their entire life cycle. This approach enables the integration into new cements while ensuring compliance with sustainability requirements in all three dimensions. Thermodynamic modeling will predict physicochemical changes in phase content as a function of composition. Here's an example. Sodalite is a significant component of red mud. It has a potential application in forming cementitious phases. Beyond the recycling of secondary materials, CARE will pioneer the development of CO2 neutral and even CO2 negative cements. Yes, it's feasible. We have developed an electrochemical cell that couples formation of mineral binders with water electrolysis. During binder formation, hydrogen and CO2 are released separately. The hydrogen can be used as fuel, while CO2 will be used as reactant to synthesize polymers or for carbonation of mineral binders. When using magnesium silicate and other minerals such as olivines, this method enables cement production without any CO2 emissions. The resulting mineral binders can furthermore act as CO2 sinks, paving the way for CO2 negative concrete. The CO2 integration offers new possibilities for reinforced concrete. Renewable fibers like flax or hemp or circular reinforcement made of glass or basalt were previously unsuitable due to their low durability in highly alkaline environments. CARE will solve this by binding CO2 into cement matrix, reducing its alkalinity and enabling the use of such reinforcement. And it is really a breakthrough in concrete technology. Advanced microstructure quantifications and data-driven material designs will enhance the resilience of these novel fiber matrix combinations while minimizing the use of raw materials. Digital fabrication techniques will allow the prefabrication of elements with complex geometries. For instance, the automated production of rib slabs reinforced with carbon textile uses only half the concrete of traditional ceilings while maintaining structural strength. Furthermore, CARE will inject CO2 directly via the printhead. Combination will change chemistry and rheological behavior of the fresh mixer and lead to accelerated strengthening of deposited material. Our slab designs draw inspiration from Virgin Nevis' iconic structures. However, Nevis' approach relied on labor-intensive curved formworks, making mass production unsuitable and impractical. CARE revolutionized this concept by leveraging advanced digital fabrication technologies to produce the slab efficiently. Moreover, unlike Nevis' monolithic designs, our slab will be modular, featuring detachable connections for easy dismantling and reuse. By integrating sensing fiber reinforcement, the structural members will gain entirely new functionalities. Multimodal data collection in real time will enable machine learning models for predictive maintenance, detecting cracks, and monitoring ingress of critical media and salts. The sensors will be self-powered, utilizing thermoelectric energy harvested via the Seebeck effect. CARE will enhance the efficiency through chemical doping and nanomodification at the fiber level. Well, in CARE, we set bold goals to catalyze a groundbreaking transformation in construction. Over the next 7 years, CARE will deliver disruptive methodologies to enable carbon-neutral building practices. Our research will also lay the groundwork for massively reducing resource consumption and waste. CARE will also provide pioneering methods to boost the resilience and adaptivity of structures, extending their service life well beyond 100 years. By entering the human factor, CARE research will significantly enhance working conditions and productivity while also making construction more inclusive. We, the CARE team, are united by our scientific interest, but above all, by a shared understanding that our planet urgently needs care. And indeed, we do care. We are CARE. Thank you so much, and sorry for this call which arrived me in the hotel just in the final stage of this presentation. Thank you again. Bye-bye.
Now we will hear from Nico Fairbairn. I hope I pronounce your name correctly. Yeah, the floor is yours.
Hello, I'm Nico Fairbairn, Head of Partnerships with the State of Carbon Dioxide Removal. For those who are not familiar, the State of CDR is a multi-institutional research collaborative that delivers clear, open, up-to-date, and independent data on the state of carbon removal. That means carbon removal science, policy, technology, and markets. To date, we've delivered 2 authoritative reports on the state of CDR, and a third is in the works for 2026. So today I'm going to be presenting on the intersection of carbon removal with the built environment. Next slide, please. Oh. Perfect. So to kick things off, I wanted to create a shared understanding of what exactly carbon removal is. We borrow the definition from the IPCC, which defines carbon removal as human activities that capture CO2 from the atmosphere and store it durably in oceans, land, or other terrestrial ecosystems. And we like to constrain our definition of CDR through 3 principles. One is that the CO2 must be captured directly from the atmosphere, and this helps to distinguish CDR from, say, carbon capture and utilization and storage, because the CO2 needs to not come from flue gas or combustion of fossil sources, but rather directly from the atmosphere. Secondly, the subsequent storage of CO2 must be durable. And here I just want to note that there is no commonly broadly agreed upon definition of what durability actually means. It's quite context dependent. The IPCC does not define it in their definition of CO2, and so we take a bit of a broad interpretation of what durable means, but in general you can think of durable as storing CO2 on a scale of decades or more. And a third principle is that the CO2 removal must be additional to Earth's natural processes. So it need to, in a counterfactual scenario, it need to have not occurred in order for it to be considered CDR. Okay, next slide. So also to put CDR in the context of the broader climate problem, you can see here a graph of our emissions trajectories and the roles that CDR can play in helping us to stay Paris aligned. First and foremost, and central to climate response, must remain the rapid and deep reduction of emissions, but with that we must also focus on CDR can help us to reduce our net emissions, and in the midterm CDR can help us to reach net zero by counteracting residual emissions, and in the long term CDR can help us potentially to come back from overshoot and maintain a net negative state for society. So there's a lot of potential roles that CDR can play in helping keep us aligned with Paris temperature targets. Next slide, please. So here I just wanted to flash up some images that might conjure up your conceptions of carbon removal. There are many different kinds of CDR ranging in their technological readiness level, or TRL, ranging in the potential carbon removals that they can deliver, as well as crucially the durability of storage. And so just some examples are direct air capture, a suite of different marine CDR technologies and approaches. Some are more nature-based and some more engineered or technological. Next slide, please. So as promised, today I'm going to be talking about the intersection of CDR with the built environment. Up here I'm just showing a number of different possible products. This is an area of active research where carbon, CO2 can be stored in products that are highly valuable for the construction sector. But today I'm just going to focus on mineral products and timber products. Next slide. And next slide again. Thank you. So kicking things off with mineral products, a little background about the construction sector. The vast majority of emissions that come from the construction sector can be traced back to the production of cement and concrete, which accounts for something like 8% of total anthropogenic greenhouse gas emissions. And the construction sector, you may have heard in many UN spaces that something like 75% of infrastructure that is to be in place by 2050 has yet to be built. As such, construction sector related emissions are projected to double by the last I saw was 2050, and the previous presenter said 2060. So we're expecting in any case a massive increase in emissions from the construction sector. So for mineral products, given that the cement and concrete are such a large portion of emissions from the construction sector, that also presents a really big opportunity for CDR to help us avoid and potentially even remove and draw down net negative emissions. So how we do that is through a chemical process called mineral carbonation. The equation for that is on the right-hand side of the slide, and essentially you're exposing some kind of alkaline feedstock or source of alkalinity to atmospheric CO2, and through that process creating solid carbonate minerals, which are actually the building blocks for all kinds of high-value, highly relevant construction materials, like asphalt, precast concrete, and even some gypsum, some replacements for gypsum-based materials, like fire retardant. So I also wanted to highlight that the alkaline minerals that can be sourced for this mineral carbonation process can come from many different sources to help create a circular economy, or you can source your alkalinity directly from the environment through mining. There's different trade-offs associated with each, but I would just highlight that if you're sourcing your alkalinity from industrial waste streams, you're helping to divert those wastes from landfills, reducing pressure on landfills, and also with an added benefit, many of those industrial waste streams actually are more primed for the mineral carbonation step and require less energy and therefore less emissions in order to be converted into these highly valuable construction products. Crucially, as I mentioned at the outset, one of the principles of what makes CDR different from CCUS is that the CO2 needs to come from the atmosphere. So in order for these to be considered carbon removals, the net emissions from the product needs to be negative. And that can happen in a number of different ways, one of which is that you couple the mineral carbonation process with direct air capture or bioenergy and carbon capture and storage to generate the product. And additionally, some monitoring would need to take place in order to ensure that the CO2 remains embedded in the product. Additionally, as many are maybe aware, cement and concrete can actually draw down CO2 after it is laid throughout its lifetime. But more research is needed to understand at what point cement or concrete becomes a net negative, or if at all it becomes a net negative product. So jumping to the next slide, I'll talk briefly about durable wood products. A little bit of background about timber. Timber has been used as a resilient building material for even multi-story buildings for centuries, but the vast majority of our buildings today are built with steel and cement. So once again, we have this opportunity to mitigate, avoid, and potentially remove CO2 by replacing steel and cement building materials with timber-based ones. So a study was conducted that basically looked at if we were to supplant a number of building materials for new urban population growth with timber, with wood products, how much emissions could we avoid? This study found that if 90% of new urban population growth was met with timber cities or timber buildings, we could avoid something over 100 gigatons of CO2 by the end of the century. And I'd also like to add what makes these products promising is that durable wood products also have a number of co-benefits that can help to make them cost competitive with pre-existing counterparts on the market. Things like air pollution is improved in buildings that are made from wood, as well as energy efficiency, earthquake and fire resistance, less waste at the construction site, and even faster assembly of buildings when using wood. So all kinds of benefits, whether you're talking about durable wood products or mineral-based products, they need to be cost competitive with current products on the market because there is resistance to adopting new materials simply for a climate benefit. So it's helpful when they can offer more than a climate benefit, but be cost competitive and have other performance-related benefits that they deliver. What I would just caveat here is that in order for durable wood products to be considered carbon removal, we have to look at the entire full life cycle assessment of the products and understand how that timber was sourced. Ideally, some regrowth or replanting is following the harvesting of the timber. You've got strong sustainability sourcing standards, forest governance measures, and forward-looking land use planning to help ensure that durable wood products are actually removing carbon over the entirety of their life cycle, and also paying attention to their the harvesting's effect on land use dynamics, biodiversity, and human civilization. So with that, I'm going to close. Next slide, please. Yeah, so if you'd like to read our second edition report, there's a lot more data about the state of carbon removal, and you can scan this QR code here. Thank you so much.
Thank you for sharing your perspective and also showing how carbon dioxide removal can play a stronger role in the construction and building sector. Now it's time to hear from all of you, and I would like to invite Professor Gointer to moderate this part. No, the previous. No. Yeah.
Yeah, so we thought we are just interested in your reflections on the presentations and where you see what we should prioritize when we discuss the working groups in the priority action research. Any ideas? Finland. Any idea or from?
Well, I think one of the most important things at this stage is that we move beyond the innovation phase. As has been said, right? There are a lot of solutions out there that are ready to be skilled, but the only way to skill them is if we have cross-sectoral collaborations in place, and therefore you will need to establish working groups that actually connect up to one another, maybe in different type of settings or formats, in order to prevent siloed thinking, in order to prevent securing the maximum amount of impact of the solutions that are, again, already out there and ready to be skilled.
Thank you so much. So do you already have any idea for formats, just in case you can reflect about that? And then my suggestion would be that we then set up those formats already in Lausanne to have some for the next assembly in April. I think that's a very good idea. More ideas. Very good. You had an idea? So that what Malia points at you. Okay.
Can you just repeat the question?
Sorry, I just came in.
So the question was, what can we take from the presentations here and from the discussion for the working groups in the priority action research? What could then also be coordinated for Lausanne, maybe?
Thanks. Yeah, I'm sorry, I'm late. I missed the presentations because I was listening to the Just Transition presentation just in the next pavilion. I'm Joscha Rosenbusch. I'm also working in the context of the Global ABC. I'm co-chair of the Finance Hub, so maybe the perspective comes from there. In the Finance Hub, we have been looking into innovative financing instruments, including Article 6 of the Paris Agreement, which is about carbon credits, right, and how it could be used. And what we saw is that the biggest potential for carbon credits in the building environment is actually in the construction material, not so much in the operations. Yeah? In the operations, there is some space, but it's quite difficult to tackle because you have very small interventions of, I don't know, replacing a specific technology, and it only needs to be aggregated to a big amount to make it relevant. But in the, let's say, in the construction field, so the building material, there's a much stronger case to use carbon credits on the financing attached to it to decarbonize. So I think elements that relate to cement and steel decarbonization are, let's say, from our perspective, from the financing side, in this particular instrument, something that we should continue to explore. In the program I'm working with in GIZ, which is the Partnership for Energy Efficiency in Buildings, we are currently working in 3 countries on establishing a baseline on emissions for specific building sectors, and are trying to identify some possible projects that could be, let's say, developed as carbon credit projects to be issued as ITMOs on the international market. Potentially, I don't know, Norway could then catch them up, or Switzerland, who is quite active in this. But there's more, let's say, research that needs to be done, and also there's more, let's say, practical experience that we need to gather in order to see how these projects can actually work. And maybe that's one of the topics where, I see a connector between the 2 working groups or hubs, no, that we have at the Global ABC.
Yeah, very good. So the feedback I take from this, or do you have any other thoughts? Yeah, a reflection?
Yeah, two things that I didn't really cover in my presentation that I think research could focus on. One is I think I alluded to the fact that there's some resistance in traditional markets to accept new materials unless they are cost competitive and deliver some kind of co-benefits. So there is research that is needed to study social acceptability and uptake of these new products and what barriers there are to contractors being more open to these climate-friendly alternatives. Additionally, for the mineral carbonation products, there is a lot of research that still needs to take place about how you prepare your alkalinity sources, which alkalinity sources over their entire life cycle have the lowest net negative emissions, and as well as the heterogeneity of different mineral sources and the ultimate performance that they deliver. So more studies to understand also how you can scale up those different technologies in the mineral carbonation space.
Thank you so much. So what I take away from the reflections is that we have to go one step further. So the survey presented us topics, but what I hear from you is that we should connect it already with the business sector, with the implementation, not only the innovation, connecting it to the finance sector and connecting it to barriers analysis. And maybe that type of thinking then already helps us when we come to this, what I presented earlier, the theory of change logic. So why do we do all this? We do not, of course, we are scientists. We also want to produce more papers, but that is not why we are here at COP, but that we go beyond. And I see for all three ideas a way forward to create impact and really to make the change in all three areas. Thank you very much. So I hand us back to Asil.
Thank you for sharing your feedback. And now I would like to invite our panelists to discuss about our topics actually. And firstly, Professor Günther, Director of the United Nations University, please take a seat. And then Christian, the founder and executive director of the CDR initiatives, please. And next, Mina Hassman, Sustainability Director, the Skidmore, Awnings and Merrills. And Nico, Head of the Partnership at the State of Carbon Dioxide Removal. So, thank you. I would like to start my first question to Professor Günther. So, how do you see the collaboration between the material scientists, structural engineers, architects, and policymakers shaping the next generation of the sustainable construction research?
So what I think, so shaping the next generation, maybe I would even also reflecting on what we discussed before, go even one step back and challenge your question in that sense. Do we already need a next generation, or do we just need to implement what's already there and in parallel think about a next generation? So that could really also be a way forward, because what we also observe is that very often if things don't work out, we invent something new and it still doesn't work out, and then we have a next generation and a next generation and a next generation. So that the next generation could be the implementation and fine-tuning of what is already there. And in parallel, I see a huge potential in cross-disciplinary collaboration, like, for example, energy storage in buildings, so that we have decentralized energy generation, and we store energy in supercapacitors in the wall, for example. So again, that we bring together disciplines from different areas, also engineering, not only the social scientists and the engineers and natural scientists, but also different engineers.
And I also think that this is really important to translate for example, the research results into the practical solutions in the real world, actually. I think that is really also important. So my next question is to Mina Hassman, actually. So where do you see the biggest disconnect between the research, practice, and policy? And how can global networks, such as the Global ABC, actually can help the bridge it?
Sorry, do you mind repeating the question again?
Yeah, where do you see the biggest disconnect between research, practice, and the policy? And how can global networks, such as the Global ABC, can help bridge actually this?
I think the biggest disconnect currently is knowledge and implementation, because in academia there is a lot of wonderful research that is going on, but it's usually in silos, and I'm saying that with a big caveat because at SO1 we do a lot of collaborations with universities, but that's only a few handful of private sector organizations that are doing that. I think that in general, most of the research happens in silos in academia, and there is a disconnect of transfer of that knowledge that is gained through that research into practice. And practice really needs very urgent, implementable solutions, not just things that work on paper, but they need to be tested on the ground. And then also policy lags behind because there is no evidence to demonstrate how some of these solutions can be implemented in real practice. So I think if we could tie back all to Christian's earlier point, if we can tie every sort of key stakeholder, decision maker together and actually start doing research, co-creating this research ideas together with practitioners, academics, and even policymakers, then I think we can significantly accelerate the solutions, the implementation, adoption of those solutions on the ground, which is very critical. And that's why organizations such as Global ABC is critical, I think, to bring all of these key stakeholders together, but also create platforms for them to exchange knowledge, because it's easy to say everyone should come together, and I know realistically it may not be possible in every place around the world, but if there is a platform that they can share this knowledge, that's already a step ahead to where we are today.
So may I just reflect on, because it's a discussion, right? So I just jump in. So Mina, you said we have to bring them together, and I fully agree with all that. I'm always wondering how we can change the incentive systems for scientists. Everyone tells me, oh yeah, that's important that my ideas get implemented. But then if you ask them to go here or to collaborate with practitioners, then they say, oh, but this creates opportunity costs. I need to write my next paper. And I really think that the incentive system in universities and research institutes is really wrong, that they focus so much on impact factors of journals, citations. So I was just thinking while listening to you, what could we do at also Global ABC to push this at least for the buildings and construction sector?
It's a really great question, a difficult one to unpack, but I'm going to try a little bit. I think maybe the government fundings and for co-partnership or co-created projects between academia and industry could be a way to incentivize academics, especially to join into ventures with practitioners, and likewise, because practitioners say we're too busy delivering projects on the ground, we don't have the time to invest in research. I think I'm blessed to be working in an organization like SO1 where we have the separate entity where we invest time and money internally to be able to explore ideas that are beyond today's best practice, but that's very handful of organizations. So to be able to make that standard practice, I think there needs to be more government-funded projects, initiatives that encourage by default for academics to come to join together with practitioners and vice versa, and even policymakers. I would say it's really important.
Yeah, but you think that how can academia and industry co-produce the research that is more applicable to the building design, construction, and operations?
I think maybe I can briefly touch upon a research we've been investing in for the last few years, which we launched at COP26 a few years ago. It's called Urban Sequoia, and we envision, it's a big, bold idea, but we envision buildings acting like trees and absorbing carbon from the atmosphere. In that, we've been collaborating with subject matter experts of carbon dioxide removal, technology producers, as well as bio-based material scientists, because we're architects, engineers, planners, but not material scientists or carbon dioxide experts. And we've been also collaborating with the University of Colorado to be able to advance especially the bio-based material side of the story. I think, and that was an incentive from SOM to engage in this research, because we believe it's really important to think about what's the next big move that we can do in the built environment sector to drastically accelerate not only decarbonization, but going beyond net zero carbon. I think that, projects as such, but again, I think those projects are very handful. It's not, I'm sharing this to demonstrate that there are viable projects as such beyond the ones that we're working at SOM that are happening between industry, academia, and also various subject matter experts and manufacturers and so forth. But to be able to scale these kind of research, which SOM is investing their own money in, which is not sustainable in the end for many organizations, we need more government-funded initiatives and projects and incentives to bring everyone together around the table.
Yeah, thank you. So my next question is to Febrerin, actually Nico. So much of the conversation around the carbon removal focus on the land and energy systems. But from your perspective, what unique opportunity does the built environment offer for the durable carbon storage through the material design or urban system?
Yeah, so today I presented on just two of the many ways that carbon can be stored durably in the built environment, durable wood products and mineral carbonation. One of the take-home points that I think I'd like to drive home that's a key opportunity that the construction sector presents for CDR is really this opportunity to create markets for CDR. So one of the perennial issues of carbon dioxide removal is that we just don't have enough demand for CO2, because to date, most societies have not put a price on carbon. We have not internalized the cost of carbon, and so the CDR pathways rely almost entirely nowadays on voluntary carbon market. In fact, companies like Microsoft are are very disproportionately responsible for all purchases of novel CDR. So one of the really exciting things about the built environment is that it presents a consistent source of demand for carbon removals and can help to fund and then scale CDR technologies and research. Secondly, and this is a point that I've made before, is about the ability to divert waste streams and reduce pressure on landfills. So if you take existing industrial waste streams that oftentimes do not have another end use, such as steel slags, coal fly ash, brine from desalination plants, mine tailings, and these things called air pollution control residences, which emerge from incinerating municipal solid waste. All of these industrial waste streams can then be serve as inputs for construction materials. And then lastly, I think it's obvious, but the construction sector presents, given that it is such a high carbon intensity sector, it presents a key opportunity for avoiding emissions at a huge scale and potentially even helping us to get to a net negative state.
Thank you. My next question actually is to Christian. Thank you. Please. Yeah. So, from your experience working across the climate innovations, industrial decarbonization, and urban system, what do you see as the top research priority the global community should focus on?
Yeah, that's a very good question, which I won't answer immediately, because I think I would like to say something else first, which is that there's a big question around how we move beyond the innovation phase. I think that sort of lingers in this whole discussion. Solutions are out there. We've done a lot of research. There's no fundamental research needed. Let's go cracking and get this skilled up. But somehow we get stuck in that. SOM, is an example in a way of going above and beyond in their thinking, but then being facing all these barriers and actually implementing some of their innovative ideas, such as the Urban Sequoia project. Now, we recently developed a new sort of vision that in a way expands on that Urban Sequoia design concept. It's a vision document with various partners that we developed with SOM, and including Conservation International, UN High-Level Climate Champions, Carbon Neutral Cities Alliance, X-Prize, and the City CDR initiative. And that focuses on carbon sink cities, the idea that an entire city can become a gigantic carbon removal system, in fact. and even more, a node in a global carbon removal architecture, which is what we need. I mean, as Mr. Rockstrom said, 1.5 degrees is now out of sight, right? Overshoot is inevitable. So we better start designing our cities in order not to reach climate neutrality, but to actively start restoring our climate and regenerating our environments and our communities. So if you want to ask what the research priorities are, then it is about, first and foremost, changing our frame of reference. And that is not only needed in terms of the research community, but also in terms of, indeed, the governments, the public sector, in order to help set up that kind of collaborative architecture that allows for the scaling up of these innovative ideas, to the levels that we need. Now, just to sort of put that into further practice, my thinking is really this. So yeah, thematic research priorities are great. That's good, and we need to continue those, and they've been highlighted by you as well, right? But I think building on what I already mentioned, that in the intervention, I think we need to start focusing on the nexuses. Where does carbon removal interact with climate change adaptation and resilience building? How can it be integrated in our emission reductions interventions? How does carbon removal and circularity relate to one another? Can we, move towards a circular economy that also absorbs carbon at the same time? We are very far from understanding the interactions of these systemic ideas on the way that we want to design the cities of the future, our societies of the future, including all the behavioral change that comes with it, right? So, thinking about those kind of nexuses is important, and then, if we really want to sort of go into thinking in terms of sort of how we want our cities to look like in 2050, then we need to look at cities from a complete systems perspective. How do all these various models interact with each other within a larger system? What does it mean for the carbon fluxes if we start to try and integrate carbon sinks across the built environment, across the urban systems and infrastructure that we have in place? How do we measure all of that, right? And, Nico knows much more about this probably than I do. I have very little ideas about carbon fluxes. But, one thing is that I do know is that we don't know a lot about what happens when we start integrating carbon sinks across the built environment. And so this is a big research agenda, I think, and it expands, I think, on what Edeltraud has mentioned. And it's very complex to even formulate it, so I've tried my best and frame it a little bit.
I just wanted to add something to it. I think it's so important to think about at that systemic level, because we talk about in the Urban Sequoia project, we think that the buildings can absorb carbon, but where is that carbon going to go? How much of storage can you have especially in a densely built cities? And if we envision that the cities can become carbon sinks, we need to also be able to understand where is that carbon going to go, and how can carbon be used as a much more valuable resource than it is today to be able to supply the economy. We talk about the net zero carbon economy by 2050. So I think it's really important to be able to investigate and dedicate time in research to understand how practically all of that could happen, because not every places around the world will have the right, and Nico would know this better than I do, but right sort of terrestrial sort of ecosystems or conditions to be able to inject the carbon back into the earth. So I think we need to be able to, when we're thinking of these big, bold ideas, we also need to understand what's going to happen, what is the next step, what is the consequences of that solution that may be implemented at scale to be able to drive carbon reduction at fast and pace.
Yeah, and what municipal governments, national governments and international institutions can do is establish the platforms for these kind of value chain focused collaborations that allow for that allow for the interaction between all the relevant sectors and players that need to come together in order to implement these ideas within a particular value chain. And talking about industrial value chains is a good starting point, I think.
Thank you for sharing your perspective. I also would like to invite audience, please feel free to raise your hand if you also have any question, or if you would like to share your feedback, or John? Okay.
Yeah, I wanted to ask a question to Mina. I mean, I don't want to put you really on the spot, right? But I come from a policymaking environment that used to focus on CCS. And one of the big disruptors of the conversation around the relevance of CCS was the constant input of the idea of CCU, the promise of CCU. But the reality is, of course, that the excess of CO2 in our society is such that initially it is a waste product. And more needs to be stored, including from what we capture from the atmosphere, than that we can use. There is not the demand for CO2, and certainly not at the scale of what we emit, certainly also not on the scale of, and it would have to be in any event complementary to what we actually draw down and put back into the Earth systems, if you will. So how do you feel about, on the one hand, communicating the idea that CO2 is a waste, yet on the other hand, and in line with what I just said, on the other hand, communicating the idea that CO2 can become a resource in a future, in a future economy. How do you do that?
Well, I think it's a very challenging ask at the moment, because if we say CO2 is a waste, which is true today, then we already lose the hope that we can give to people to say, well, CO2 is a waste today, but keep doing it because in the future it's going to be needed. So I think that's why I spin the narrative and I say CO2 can and should become a resource, and it will eventually. I don't have a crystal ball to gaze to say that CO2 is going to become a fundamental resource for our economy to run in various sectors. But even today, we know pharmaceutical sector, for fizzy drinks and other things, you need CO2. And I'm hopeful that there will be more demand of it in the future. And I rather, even though realistically I know deep down it's a waste today, I rather focus on the narrative of the hope so that people can actually act on it, because I think only with the positive, inspirational sort of end goal that people can change their mindsets and do something different than today's best practice, which is not enough.
So I would like to add on that, and I also agree that it's always gives a specific connotation when we speak about waste. And therefore we currently developed a concept for a house of no waste, meaning nothing is wasted, but everything is seen as material, so no waste of energy, no waste for the climate, no waste of water, and so on. So we have here the QR codes just for everyone. It just came to my mind, that was not planned, but as you spoke about that, I just thought this is the perfect moment that we also flip this understanding of what you actually say, that is it really waste, or do we need to have a different understanding? So thank you very much.
Yeah. Thank you all for sharing your perspective and very fruitful actually discussion now, and also thank you all participants. I would like to actually ask Edel to share her concluding remarks as a last part.
Yeah, so I think we collected already many ideas. What we said in the first round, it was focusing on the finance sector, focusing on implementation, focusing on barriers. What I also think, tapping on what you mentioned regarding that funding should be connected to all those ideas of implementation. So I would like to invite everyone, also those watching this session later, to come back to us and give us ideas for working groups, giving us also ideas for the next annual assembly in Lausanne, where we will then continue the conversation. Of course, we will continue in between, but that we then for April already have first results. Thank you to everyone, and back to us soon.
Thank you. I think that we can wrap up for our today's session, and thank you everyone, and yeah, thanks. Have a good day.